Hello out there in remote learning land once again. Might be a little background noise today. I apologize for that, but shouldn't be too bad. All right. So for the last couple days, we've been talking about different weather variables, right? We've been talking about pressure, temperature, humidity, the instruments used to collect that data, and how you can use that to help make a forecast, right? To interpret the weather. Anyway, today we're going to talk about how to organize that data, because if you think about it, if you collect all that data from every town in every state across the United States, it gets overwhelming, right? It's just an enormous amount of data. So there's a system that they use that helps organize it, makes it easier to study, and make more accurate predictions. All right, and that's what we're going to talk about today. It's called station models, and we're going to show you how to construct those and, of course, how to interpret them to make an accurate forecast. Okay? Okay. So this, of course, is a local topographic map of Elmont, New York there. And, each day you get all different weather readings. And we're going to organize those all around this little circle here. All right? It all starts with the circle. That's the base of the station model. And then you put the data at specific places around the circumference of the circle, and you have to be consistent with that, right? So it matters where you put the data because that's the only place it should go. And when other people get the station model, it's uniform. You know what I mean? It's written the same way as you did. All right. So first, of course, what you got to do is you have to get some data. So you go to a reliable site and see if I can find a reliable site here. And let's see. Okay, so let's say you go to, you type in your Google, you go weather in, is that coming? Oh, it's not coming up. 1 second. Not sure why that's acting funny there. But anyways, so you type in, weather for Elmont. And, you get your precipitation, your humidity, your wind speed, your temperature. And it's all on here, but it's all over the place. So we want to condense it onto a weather station model. So we got 50 degrees Fahrenheit. By the way, weather stations are in Fahrenheit. So you have to convert when you go to that dew point chart if you need to, right? Those are in Celsius. And you get all this on there. All right. So let's go to that chart there. And we'll put our 50 degrees where it belongs. All right, so the temperature is going to go up here on the top left. $50 degrees. And it's understood that it's in Fahrenheit. You do not write degrees F. All right, if it's a Regents question, believe it or not, they take credits off if you write units on here. Every other thing with every other, problem, we need to use units, but not in this case. All right. It's saying the visibility is 2 miles. So that goes right below here. That 2 stands for visibility. Wind speed was dying down, obviously. It was much faster the other day. But just for argument's sake, we'll say it's 25 knots to show you how to do it. And let's say it's coming from the north. Let's say it's coming from the southeast. So you draw a stick to the southeast. And for 25 knots, you use different feather configurations. So a big feather is worth 10. So that would be 10 plus 10, right? That's 2 big feathers, and a baby is 5. And that would be 25 knots coming from the southeast. Winds that describe where they come from. Okay? It's a very dry day. The temperature is very far from the dew point. The dew point today is roughly 25 degrees. That goes below the visibility. But it's in a good spot because it allows you to compare temperature and dew point, which are very important because remember from the other day, if they're close, that means the air is very humid. If they're getting closer, that means pressure is dropping and there's probably going to be a big storm. These are very far apart, right? It's extremely high pressure, and that's what's going on there. Okay. As far as air pressure, you would get a barometer, right? A reading from a barometer. That would go up here. So let's say the pressure was, 10, 20 millibars. There's a special way you got to do it. You can't just write 10, 20. There's that, 0.0. You actually have to change that. They abbreviate it, which they would get rid of the 1, the 0, and the decimal, and you'd be left with 020. I know that sounds a little strange. I'll show you more how to do that in a second, but that really would stand for 1020 millibars. All right. Over here would be the trend. What has happened to the pressure? Has it increased? Has it decreased? We had that major storm a couple days ago. So let's say the pressure has gone up, obviously, since then. Let's say it's gone up, 7 or so millibars. So it'll be a plus 7, meaning the pressure is increased by 7 millibars, and that's a good thing. So it makes sense. The temperature and the dew point are far apart. The pressure is high. It is continuing to rise. This is a nice day. Of course, it's a little windy, but it's a nice, clear, cool day. And as far as the cloud cover, well, there are some clouds in the sky. Not much, obviously, if you look outside. So maybe about 25%. So they do this little pizza thing here. Oops. And they'll make like a slice of pizza. So for 25%, that would look something like this. And you would shade in 25% of that circle, and that indicates 25% cloud cover. Okay, that doesn't mean it's going to rain. There certainly could be fair weather clouds, which the high pressure alludes to in this case. All right, the other thing that they put on here sometimes, the precipitation in the last 6 hours. There hasn't been really any, so we'll just put 0 right there, and that's showing you the precipitation in the last 6 hours. Now, there are other symbols I'll show you on the next slide here, but that's the basics on how to construct a weather station. And it's done the same way every time for every town, every collection of data session. It's all organized that same way. All right? Let's keep rolling here. Let's see. And I'll get a full screen here. Okay. So how do we make it easier to read weather conditions at Elmont? Well, here's your reference tables diagram. It tells you where every point goes. It labels it. This is just an example of it, right? This isn't every day, obviously, but the position, of course, is consistent all the time. A couple things I didn't put on the first one. You'll notice I didn't put a present weather symbol. There is no symbol for just sunshine. The symbols usually are for more threatening type of conditions, but that would go right next to the visibility. There's a little slash here next to the 19 that if it's that way, it's a steady rise. If it's this way, it's a steady drop. It could do a couple different things, but that direction of that line tells you the trend over the last 3 hours. There's your rain over the last 6 hours, right? Your wind, stick, and the feathers. And again, this is all in the reference tables. You don't have to memorize this, but you do have to know how to read it. Okay? Converting pressure like I did before. So let's say you get an actual reading of 982.5. Well, to convert that, you're going to remove the first number. Okay? First number goes. Then, of course, you're going to remove the decimal point. Right? That goes. And the unit goes. So what you left with in this case was 825. So again, you started with 982.5. But they try to abbreviate it so that you don't have too much stuff on those weather stations. So they cut the first number, the decimal, and the unit. Okay? And that, of course, is what goes on the upper right side of the weather station. Okay? 825. All right? Station model pressure must always have 3 digits. So when you're doing your conversions, make sure you end up with 3 digits. All right, a couple practice ones here. Right, 998.2. Well, get rid of the 9, the decimal, and the unit, and go for it. Hit pause and practice a couple right now. All right. Hopefully what you're left with here is simply 982, right? Over here, same thing. Chop the first, the decimal, the unit. I know this one seems weird, but you would have 000, right? 000. And this one here, see if you could figure that one out. And we'll, of course, we'll go through that when we meet back in the meet. All right? What I'd like you guys to do once you finish those, construct this station model using this data. Okay? Make sure it's in the proper place. I'd love to have you guys screen share in a minute or so to show us how you did on that. And there is a second one to construct as well. So you have 2 station models to construct, and of course, a couple of summary questions after that. All right? See you guys in a meet.